I'm Glenn Thacker.
This is my screaming fan motor. And in this project, as I turn on the switch, allowing electrons to begin to flow from the negative side of the power source, conventional current will begin to pass through a motor. The motor will power on. Depending on the level of resistance, and the speaker will emit sounds. It incorporates a slider switch, speaker of course, two capacitors, one at 0.1 microfarad and one at 470 microfarads. We have a couple of transistors working in series, an NPN, sending a charge into the base of the PMP, and to allow the conventional flow to go through the speaker, making the sounds depending on the variable resistance. And in addition to the variable resistor, we have a 100 ohm resistor and the motor itself. As electrons flow from plus 0 volts, or the negative, it allows conventional current, or Q, to fill the holes left with current. The base current is 0.25 amps, which is just enough to power our speaker. The variable resistor adds 0 to 50 ohm resistance to the circuit. We know if we have 0 resistance on our variable resistor, we need R1 at 100 ohms to keep that base current down far enough so as not to overblow the speaker. The transistors in series create the push-pull effect, which enables the oscillating wave that allows the speaker to emit sound. When a variable resistor is set to 0, as I said, the current must be limited by R1. Without R1, our components would be overpowered, because with the variable resistor set to 0 and no other resistance in the circuit, we know the formula for power is power equals voltage squared and then divided by resistance. So that would be 2.5 volts squared at 6.25 divided by 8 ohms, giving us a resistance or giving us a current or power of 0.78125 watts, and that excess current would overdrive and damage the speaker. The motor contains 3 coils of wire in loops, and when current passes through the motor, that current creates a magnetic field similar to a magnet. And if the current is big enough, it will cause the loops to begin to move. And once the coils begin to move, there is another permanent magnet inside that motor. And once aligned with those coils, or actually once the spinning coils are aligned with the permanent magnet, that will cause the fan motor to start spinning. Now with R1 at 100 ohms, along with our variable resistor at 0 to 50, our resistance is anywhere between 100 ohms and 150 ohms. And at 150 ohms, the speaker's still working, but it's much more limited current coming through. So you'll hear a small whine from the speaker. And then working once again in conjunction with the capacitors, it has to build up a charge once again. And even at 150 ohms resistance, it will build up for a while and the fan will start moving once more. And using Ohm's law to calculate the variable in that resistance, at 100 ohms resistance, we already know we have 0.025 milliamps. And then with 0 to 50, it could go anywhere from 0.0166 to 0.025.